Hello, CIS30C. In this video, I'm going to go over lab 10. And in this lab, we are going to do static code analysis using Python tools such as Dlint and Pylint. I wanted to expand on this a little bit more, as in the lecture, we mainly covered some of the other Python modules. And in cybersecurity, you will often see that we require analysis of code and for the applications. Okay, so you can find the lab information posted on Canvas, and once you download the document, you would see lab 10 instruction here. To begin, we can start talking about what static code analysis consists of. So the goal of this is to really identify potential problems. And using the tools have rules and also test templates for you to use. It's important that we think about how we can configure. So it's best to really refer to the documentation to see how you can modify the tools to suit the needs for a specific type of code or a certain emphasis for organizations. So in static code analysis, we want to find issues in the code, and we want to make it as low cost and efficient as possible. So running effective analysis requires some areas of challenges, and we need to overcome that. So to really simplify it basically, we use a module in Python to go line by line and identify different areas. And in order to read it line by line, it's need to parse through. So when you parse through a long program or a short program, sometimes it would output the result as error. And when you do this, you have to pay attention to how the code syntax would be. So in some cases, if the operators or the separate the comma, the separator for your objects are not consistent to what the rules would be, it would also show error. So the first tool we're going to use is called Dlint, and in the chapter it talks about this. So Dlint is a Python module that consists of a set of rules. We would use linter, which evaluates those rules for your code base. It would check against the rules based on best practices for Python programming. And so it uses Flick 8, which is going to be what would be used in your command line in order to assess. So Flick 8 parse Python AST, and it's going to evaluate the code line by line, and it's going to give you the output. And so from that, we can generate a report and be able to look at areas of the program, such as executable areas that we can address in the security. In this lab, you will be required to use Debian Linux. So if you're using Ubuntu or Kali, that will be fine. So once you have booted your Debian Linux, which I have here with my Ubuntu 22, you would want to start with opening up the terminal. So in the terminal, what we would do is we would, let me zoom in here. We would start with installing Dlint, and you simply use pip to install. Just like some of the other module, we would do a pip3 install Dlint. And this might take a few seconds, depending on the connection and the response of the system. Since I have previously installed it, it says that my installation has been met. So you notice that when you install this, it's going to also bring in Flick 8. And that's part of the module. So it's going to use Flick 8 in order to assess. So after you install the Dlint, what you would want to do is you would want to create a test file. Now, if you prefer to use some of the test file, you can find other test files that are available through the GitHub repo, also through the package itself. There are other resources like TOX, T-O-X, and you can find some information on TOX. So for example, if you search for TOX, TOX is really designed for you to be able to implement testing without breaking your own code. So this is used for automation process, and so it walks you through how to use TOX, and it's really aimed to standardize testing for Python. So if you can read up the information, you can see how you can implement TOX. But in this lab, we're not going to use TOX. We are going to create our own test example. So the example that we have here is from the chapter. And in this example, we are going to use pickle. Keep in mind that I put a note here that make sure that you have white space after commas and equal sign, because if you don't, it's going to throw errors, or it's going to track that as error. And for the indentation, instead of using tab, you need to make sure that you're using 4 spaces. So when I start to write the program, I can simply do nano, and I would give it a name. So in this one, it's going to use pickle, and we have an object list. It contains 3 strings, mastering Python security as the textbook calls for. We would have an iterative statement using with open, and we want to use pickle to be able to access the object list. So it's going to dump the list onto the file. Now, once you have written this code, what you can do is you can save. So we would hit Control X and yes, and enter to save. You can always come back to it using nano. So after I have written this code, what I will do is I will save the program. Then, since I'm using Dlint, I'm going to call on Flake 8. And since we're saving the program directly into our home and user account directory, we can simply run it there. If you have a test program that's located in another directory, you have to put in the path before the file name to make sure that it can locate it. So next, we're going to call on Flake 8 and our file, which is test1.py. And if it's coming back without any error, that means that it checks out fine. If you would see E and a value, that just means that it's looking at a certain line as an error. So read the message and it will point you to a certain line that would be having error. So here I put a note for that. If you have no error, then the program has passed. If it's designed to really track error. If you click this link, it's going to show you how to invoke Flake 8 using Dlint. So this is their documentation. And if you have installed it using pip3, you can simply use Flake 8. But it works with Python 3. And so 3.8, 3.9, and so on. Now, if you want to select a certain error, you can do that, or you can set up configuration for it. So it walks you through on how to be able to assess your entire project, all the files within a certain directory in that home, and wherever you save that would be local to the application or the package. Or if you don't know how to use Flake 8, you would use the option help. So in the next step, what we're going to do is we are going to obtain the statistic for all the programs we're in the current directory using Flake 8, and that will be the Python program. So then we're going to do Flake 8 and dash, and we're going to say statistics. So not only that it's going to run the assessment for this, but it's also going to run the statistic for all the other programs as well. And this will take a few minutes, so you're going to have to wait for it to go. Again, like I said, depends on your system performance. So I'm running a virtual machine. Sometimes that is a little bit slower than your regular Linux machine. So as we see this, if you go back to the documentation, it also shows you how to use different options with Flake 8. So for example, we can have it where it is not repeatable, where it's going to be quiet, or you want it more verbose, where it will show you more verbiage in the details, and so on. So you would be able to find additional options to be able to use your Flake 8 on this particular page. Now, after you get the result from the statistic, what you would need to do is you would need to take a screen capture for lab submission. So in this exercise, I intend for you to look at how you can test files, how you'll be able to obtain all, if you're working with many different Python modules in a certain location, how you would be able to use the command Flake 8 with Dlint in different areas. So we can have it less in verbosity and so on. Let me fix this. So once you get the result, it's going to give you a lot of information about all the other programs, and it depends also on how many Python packages, modules, and things that it needs to evaluate. So if you don't have as many, it's going to respond a lot quicker. Now, if you look at a little bit further, you can go to the documentation and you can look at how we can handle errors, what type of errors it is. So when you look at the errors, you can look at the code that it's giving you as the output, and it would give you suggestion on what that error would be. So the details on the error is on the error section of the documentation. If you're working with plugins and different things, you can also go here. They talk about how you can use plugins or install certain plugins. And so this documentation is thorough. It's able to give you the details on from the low entry beginning level to something that's a little bit more advanced, such as writing plugins and so on. So now I have my result, my statistic for my program. So as you can see, it evaluates the packages and it would give you a specific line when it exceeds a certain number of characters. And so the margin for the evaluation is going to be 79 characters. And so anything above that is going to track as a lengthy program. So it's also going to output that. And so anytime that you're using any packages, it's going to evaluate all the packages. So you can see. Okay. And then on the bottom, what it's going to do is going to give you some overall error code. So for example, like with indentation, so when it parses that, and if it doesn't understand or see it as outside of the rules, it's going to tell you even the white space, the tabs, and so on, or syntax error on specific modules. So here it's going to tag which module and then the type of error. So now after we have gotten the statistic, we're going to screenshot for the lab submission. In the next step, we're going to use quiet option to make sure that we have less verbosity. So it will be a summarized version of it. So again, it's going to do everything. It's going to assess all the packages. And this time we're going to make it quiet. And we will also have to wait a few minutes for it to go. Once it comes back, you're going to see the output that's going to be slightly different than this. Now the errors, they are going to be tracked similar to what you've seen in the last step, but the display that you're going to get is slightly different for the output. So once you have that, you can answer this question. How does it look compared to the previous step? Is it different? Is it the same? And so ideally, we want to see that it is less verbose, so it doesn't have as much verbiage in the details. So if you're looking for more details, we don't want to use quiet, but if you're looking for more of a summary, then we want to use the quiet option. Then, so as you can see, we have, in this particular exercise, we're going to simply use Flake 8, which does the heavy lifting as the description would say. And it's going to evaluate your code by parsing each line. And it's going to evaluate from the syntax standpoint to the risk and security standpoint. So you're going to have a catch-all using these type of tools. And so in development, why is this important? Because you really have to test your code and be able to clean up or fix the areas. We are also going to look into some of the bug area when we get to Pylint. But, to really maximize the capability of the package, we can look at the potential of the package on how we can use the actual package to really assess our code effectively. And so on the third option here, what you would have is you would have a list of options. And so if you want quiet, you can click on it and it's going to take you to the section where it would have a command line example. And then you can also set on how you want that to be. You can also use color to make it color code, or you can have it display a certain way. So it's definitely flexible in how you want to present the information after it assessed. And earlier I mentioned that you can use Tox. So Tox would work with Flake 8. So this is only one of the few tools that you would see in the industry that's being implemented for statistic code analysis. And so not only that we are looking at input validation, code sanitation, we also need to look at how the code is written and how that can impose security issues or it can create buggy problems. And so now here, when you take a look at the output, you do see some analysis in the packages. Unlike the previous command, when you have less verbosity, what you would have is it's going to simplify it and it's going to give you more of the general output instead of the actual error tracking for the individual module or packages. And so after we answer the question, we would move on to using count. And so here, what we can do is we can say Flake 8 with the option count. And again, let's wait for it to go. So when you use count, and so if you want to know what count is, if you're using the documentation, you can select on count. So here it tells you that it's going to print the total number of errors, and you can have it count for a specific folder location or directory. You can definitely get more of the general understanding of the number of errors. And sometimes if you have repeating errors, that's going to be included in the count as well. And keep in mind that when you're using a certain option, pay attention to the warning on, there's never 100% foolproof tool. So sometimes some of the tools is going to be as good as how it is created. So in this case, this is just a set of rules that's going to run against a group of programs or one program that you would have. So again, we want to really think about how we would use the tool to its most effective, in its most effective manner. No, so as you get the result from count, it would show you the listed error information. And again, it's going to check for the maximum characters. And we talked about that a few minutes ago. We touched on that. There's limitation. The limit that is set on the rules is 79 characters. So anything beyond that is a lengthy code. And lengthy code sometimes, you know, the longer it is, sometimes it would have more issues. So just the way default out of the box, what we would see is those characters are set to be 79 as a maximum. Now, when you work with more of a complex, longer program, you also, when you assess that, you would see that, right? And then it also track within the program on how certain things can generate some kind of risk. So we want to pay attention to those areas. So for number 9, as you get the result from count, we want to look at the last error that's listed. And then, and your program, your system might be a little bit different than mine, as you might have more packages and module installed. So here I have the output from count. My last error, it's going to show that it has 102 lines, which exceed the limitation ceiling that we put for the characters or when Flick is used. So 79 characters was the maximum. And so it gives you this information, and it also tells you, right, where that would be for which package. And as you look through, right, it's also going to show the type of error like E501 and so on. Now, what if I'm focusing on anything, and remember that before the option it's dash dash. Sorry if it changed to the single dash like that. So when I want to only access all the .py file, I can simply use the option file name, and I can set it with the wildcard. So we can say Flake8 file name is wildcard.py. So any of the file with the Python extension or the py extension, it's gonna evaluate. And so you can definitely do it this way or specific file like what we've seen before. So then it's going to go through and it's going to check those. So similarly, because earlier it's going to assess all the Python files, so it's going to give you something very similar to this. And also we can identify the area that is insecure. So once you have the result, you would see that it would point out things like executable or lack of input validation as security issues, or any modules that would have flaws that would impose some kind of security. It's going to be able to track that. And so what can I do with this type of information? As an analyst in either development or security, and for us, we want to look at security issues and applications, static code analysis not only just fulfill the area for the development side, but in the security side, we have to put together a report to really summarize some of the areas that we need to improve in the security landscape or the development based on what we analyze using these type of tools. So as you complete number 10, you would be able to answer this question, and it might not be, you might have to scroll up and look at the output. It might be in the middle or some other area. So you would see the result where it would say security issues. And Flake8 can also be used for bug report, and we can simply use the bug report option in order to do that. So that will be our next step. Now, when you use the Flake8, some reports are actually generated in JSON. So in the bug report, as you look at the example here, it's going to look similar to this, and it's going to give you the JSON blob. So we can use this and put it into some sort of file so that way we can include that in the reporting. Now, in some area, you have to really configure. So on the bottom of that, it talks about how you can configure using the configuration file for the actual tool. So here, what we can see is we can see that a lot of the things it's going to track that it's going to be the file's too long. And so you have to scroll up and you're going to look for certain things that might have security issues. Okay. And as we work with a lot of different security tools over the semester, if you're using the same system, you will be able to see that it's going to show. Let me see if I can find some information for you here. So it also identified things like import not being used, anything that was written in the code, but it's not really used in the actual program. It's going to say that even for some of the repository. So because that way we can go back and we can think about how we can improve. Okay. And as you can see, the type of reports that we're going to get is going to be pretty lengthy. So we have to dig through. And so this is probably better to really export it or parse it into something that will be more easier to find. So we can implement that in a way that we can use it to be able to make it a little bit better to really read. Okay, so you can configure it to really look for specific things instead of a lot of things. So it's going to track everything, and some of the areas are going to be errors. So then it's going to tell you like white space, long, lengthy program with over a certain limit of characters, class functions issues, and so on. So when I ran this to test, I saw that there was a few security, and if you're unable to find that because if you don't have a certain file that would track, okay, so here, it shows that for the test functions, which is built into DIL for the site packages, you would find that this is a security issue. So you would see that the EXEC is a security issue. So you should see that there. So it's about close to halfway up, you will be able to find. And so it would be able to track that. And then another one here. Okay. And so on. So as you can see, we do have some areas that would be insecure. So if you are running the assessment against something that has a lot of security issues, it's going to show consistently this, especially in the EXEC area. So all you have to do is go back, look at the file. Okay, so for me, test functions.py in the test directory under the DIL for the Python 3.8 site packages, and that comes equipped with the tool itself. So you can use some test tools that's equipped with the program to be able to assess. You can use talks, or you can write your own testing program. And the reason why you want to use some of the template to really test or examine is so that way you can see how the tool is responding, and also to not break your code. Then next we are going to do the bug report. So we're going to come back here. and we are going to do flake 8 bug report. And so with this, we're going to be able to find the buggy issues. So this is a little bit faster, where it's going to give me the plugin information. So when you look at the plugin, each of the plugin is listed there. So if you scroll up a little, you will be able to find the plugin information. So all you have to do is review the information and remember that this is in JSON. So it's going to list the number of plugins and the type of plugins. So for example, on the latest one here, right, that will be my PyFlakes and McCabe and Dlint and so on. So those are the plugins that it uses. Next, we are going to talk about Pylint. So Pylint is another tool that we can use for static code analysis. This tool is to check errors on Python code, very similar to Dlint. And as you saw in Dlint, it uses flake 8. So flake 8 is only one in a few that you would see. You can see that there is PyChecker or defunct, PyFlakes, and MyPy. So to understand Pylint a little bit more, you can refer to the user guide and the documentation, but Pylint is very close to what we would see as PEP8. So if you go to the user guide, it would start with the installation. We can simply do a pip3 install. And once you do the installation, you can go to the running Pylint, and it would show you how you can run it for a certain package or a certain module, or a module in a certain directory. You can run it within a program. You can run it for a program. So there are options. So when you run it within the program, you have to implement that as a Python script section for that program. So here, there's a little bit more information about the verbosity of Pylint. And so you can disable or enable certain message. So this is a way that we can control what will be output, because we might have a lot of information as what you see in Dlint. So you can generate a configuration file, or you can make it, you can mute a certain things that's going to be output. So after we looked up the information for the Pylint, we're going to go ahead and do a pip3 install Pylint. And if it's already been installed, in my case, it would show that, but yours might take a few minutes for it to go. And then after you have installed Pylint, you are going to use it to assess your test1 file that you wrote. So we use Pylint and then the file name. And here it tells you that we are missing the doc string. So that would be against one of its rule. And it's going to give you a rating, which is a score. So now if you do modify it in the past and you retest it, it's going to know that, and it's going to give you the variance from the last time that you have ran the static code. So in this case, I didn't really modify the program since I last tested. So it tells me that there's no improvement in that area. It stays the same as the rating. So once you run that, you can take a screenshot and then provide the rating for your code. Now, what we're going to do is next we are going to edit the nano test1.py, and we are going to add in a few lines. So after you have edited that, what you want to do is you want to save it with a different name. So make sure that when you open up this, before you save, follow the instruction as a different name. Okay, so here so you can simply do nano test1.py, right? Add the import line and then a few more lines for Pylint. And then we would do Control X and then press yes and then retype the name. So what I did was I saved it as a test1 pylint.py. So I added the pylint.lint import line. So we're going to import in pylint, and we are going to use the same program to assess itself. So we are going to create a list called pylint ops, which are the options. And for the options, we are going to disable lines that are too long, and we're going to test, right, test1.py. So what that will do is it's going to test itself, right, which is the code here. And then we are going to call on the run method, which is built into this particular package. And we are going to use the run method and pass the options or the pylint op that we have defined. So after that, we are going to save and exit. So to run it, you simply use a Python 3 command, and then we are going to do a test1 pylint.py. So now we can get the same result, but instead of running it on the outside, we actually write the script. We added it to the script in order to run it. And so that the reason why we save it as a different name is because I wanted to distinguish and show you different files. Otherwise, it's going to modify my file. But you can definitely resave it as a test1 and rerun it. You know, so I wanted to have a different iteration of the file so I can do the demo. So here it shows the same rating compared to the last time. Okay, so you should get that. And then if you modify the file, then we can retest it again and it would show the difference. So at that point, once you have the result, you would take the screen capture submission for the lab submission. And then what we're going to do is we're going to answer this question. Is the rating the same or different? Now, in the last few steps, what we're going to do is we are going to use, we are going to write a different file. So we are going to do nano test2.py. And in this one, this is an example from the text. I am using the subprocess module, and I am going to include Pylint to run it as a test. So I wanted to show you that there's different technique and the output of that will be different. We have a function to ping. So we are going to ping the server, and we are going to ping our own system or our Linux machine, which is going to be a loopback address. But if you are pinging a remote system, you can specify the address there on the network. And so when you're pinging, you have to issue the ping command. So this is being passed as arguments, and we would place that into a list. So here's a ping. We're going to do a count. We're going to do one ping, and we're going to ping the my server, which has the loopback address. We're going to return using the popen from the subprocess. And with that, we're going to pass the command arguments, which has this list. And to make it secure, as we talked about this in the lecture, we are going to use shell is false. Otherwise, you would impose security if you allow shell, because that can be injected. Then we are going to print ping secure for this particular IP address, which is a loopback. And the Pylint section, we're going to use the Pylint dout. So it's going to do the standard out, and if it catches the error, it's going to show you that. So when it runs, it's going to run this file, which is itself, and it's going to return the information. So after you have that written, you are going to save as instructed. And just like before, when you're using Dlint, make sure that you have white space after the comma when you write the script, or white space after the equal sign. then indentation is going to be 4 spaces. So if you're using tab, it's going to throw error. So after we have the file written, we're going to run it. So we are going to do a Python 3 test2.py. And so because this is a fairly short file, it's going to say that you have the end of line when it parsed. So it's not gonna, it's gonna look for additional things. So here it's going to show you the standard error. So that means that Pylint did work. It's just that because of the test program is not lengthy enough for it to parse through anymore. So in this case, we want to consider using something that's a little bit longer, or extend this program to look at other areas, like, you know, because it is somewhat, it checks through for the security area, but it's going to check at the end of the file, right? It is expecting the end of the file parsing. So there, what you would have is you would have the result, take a screen capture for the lab submission. And what you have here is, I want to introduce you to how to use Pylint and Dlint, which are used for static code analysis. And of course, there are other tools in the field. Since this class is based on Python, we want to tap into this a little bit more to use tools that are written or made for Python. And thank you very much for watching my video. This concludes Lab 10. Make sure that you submit your document that have lab questions, answers, and screen captures by the due date, which is next week. And have a good evening.